Hey everyone, this is part 4 on the LJ software tutorial guide. Next up, after we've done how to get the part in the field of view, the position adjustment, and a height tool, one of the most valuable tools on this entire software is going to be this profile measurement tool. Basically what this tool is going to do is you have this 3D point cloud of data, and it's going to allow you to bisect that 3D point cloud and just look at a 2D line. So let's try adding this and taking a look at what it does. So it starts off with just a blue line, just like this. You can move this blue line over here. You can move it wherever you want. You can make it shorter. It really has the ability to change however you need. What you see down here is that height data converted into a 2D graph. So I always like starting by moving this tool into a good area and then pressing this button right here. And that'll auto scale that height into a little bit more usable so you can actually visualize it. Then, in this case, it didn't blow it up as much as I want, so I can click this button right here. And then if I click on the screen and then click down here, it's basically just zooming in even more. So now you can start to see how it works even better. It zooms in more. One of the things I always like to do with profile tools is set up a zero plane. So I'm going to zero plane using a similar method that I've done before, using 3 points. So I can do 1, 2, 3. Then you'll have to recenter that range because our height did shift. And then we'll flatten this, or we'll blow this up. And as you can see, this line is now flat. Before it was angled because we didn't have a zero plane. But now that we set up a zero plane, it's straight as an arrow. What's the value in that? Well, the value is so that when you set up height tools, level differences, positions, widths, they're all flat, or they're all square, you could say. So now when I set up this height tool right here, and I measure the average height across this dime, well, I know that this area is square to this area. So my height measurement isn't going to be the hypotenuse, it's going to be that direct edge. Another great point is to use a width tool. So let's add another tool inside this profile measurement, and let's measure the width of this. So how a width tool works is there's multiple different ways that you can create or identify a point. So edge works really good for sharp rises. There's also inflection points and other different ways of getting at it. So I can drag this box over and then pull this edge up, and it's going to drop a point right there. I can do the same thing on the other side. Now I can pull this edge down, and I can open up this box. That's a great and easy way of measuring the width. Let's look at some other stuff that we can do. Maybe we want to know if this surface is angled. So a great way of doing that is measuring the angle from horizontal. Horizontal is going to be that zero plane that we set up, and then the green line is everywhere is the average height inside this box, or it's a best fit line created by all the data inside this box. So if we click done, now you can have your upper limit and your lower limit. So I'm going to increase the upper limit to 1. I'm going to put something under this dime now, and we're going to see if it fails now. So as you can see, now that I put something under that dime and it becomes significantly more angled, now at 4 degrees we're failing. So you can change limits and tolerances just by clicking on this button. Let's clear that, and maybe let's look at the height one now. So if I go to level difference, I click edit. Well, let's scroll down now. If I look at that upper judgment, you know what? This is pretty angled right now. I'd expect to see this no higher than 2 millimeters. So I can click this drop down button, click OK, and now we're failing because our average height inside that box is greater than 2.7. Now if I remove that and I scan it again, we're passing because our average height is under that limit. Profile measurements are extremely useful. Additionally, what else we can do with a profile measurement is right now we're only looking at one sliver of data. To get a little bit more averaging, which can help if there's a little bit of chatter, you can actually widen this profile. So now this data is being created with all the data inside this box. So it just averages a lot better. And then you can see how this is a lot flatter. And overall, I usually like to go at least 10 pixels wide. And to know that exact number, if you click Profile, Line, right now I'm going 120, but a pretty realistic number that you can do is maybe 20. That'll skinny up the line, but it'll remove a little bit of that noise and a little bit of that chatter. So that's 20 pixels versus 1 pixel. So you can see it gets a little bit chattery. Another great thing is you can do lots of different measurements inside this. If I want to do 2 level difference, I could add another level difference and say I want to know if this side of the coin is just as flat as this other side of the coin. So I can move a box over here, move a box over here. Hot dog, I can measure the height difference between those two. The only thing that I would like to check now is our zero plane, because it seems like there should be an angle there, when realistically we probably shouldn't have an angle. And that's because this point fell off. So I can try resetting my 3 points to be more close around the quarter, or dime in this case. And that's going to be a lot more robust. Well, again, there's a lot more that you can do with the profile measurement, but those are some quick basics on how to set up a profile measurement.